Okay, let's talk about a classic problem in probability called the random walker problem. So here's the setup. Imagine a little walker starting at position x equals 0 at time t equals 0. At the very first step at time t equals 1, it has to move to x equals 1. It takes a unit step to the right. Now here's the interesting part. From then on, the rule is that the walker repeats the direction it took in the previous step with a certain probability which we call EP. And the question we want to answer is, what is the probability that our walker is back at position x equals 1, specifically at time t equals 3? Alright, let's break this down step by step. Step 1, let's analyze that. Very first move. We know the walker starts at x equals 0 at t equals 0, and it reaches x equals 1 at t equals 1. This tells us that the first step, let's call it s sub 1, must have been to the right. So the position at t equals 1 is x sub 1 equals 1. We can represent this as starting at x sub 0 equals 0, 1 which is right, and ending up at x sub 0 equals 0, taking step s sub 1, which is right, and ending up at x sub 0, taking step s sub 1, which is right, and ending up at x sub 1. Now let's analyze the second step, s sub 2. Remember the rule, repeat the direction of the previous step, which was s sub 1 equals right with probability p. So there are two possibilities for s sub 2. Case A, the walker takes s sub 2 equal to right again. The probability of repeating the previous step is given as p. In this case, the position at time t equals 2x sub 2 will be the position at t equals 2x sub 2 will be the position at t equals 1 plus 1, which is 1 plus 1 equal to left. This is the opposite direction of the previous step s sub 1, which was right. The probability of doing the opposite is 1 minus p. In this case, the position at time t equals 2x sub 2 will be the position at t equals 1 minus 1, which is 1 minus 1, putting us at 0. Okay, moving on to step 3. Now we need to analyze the third step, s sub 3, keeping in mind our goal. The walker needs to be at x equals 1, specifically at time t equals 3. We have to consider this based on where the walker was at t equals 2. Let's look at the two possibilities for x sub 2 we just discussed. Let's continue with case A, where the first two steps were right. The path so far took us from x sub 0 equals 0 right to x sub 1 equals 1, and then right again to x sub 2 equals 2. The probability of this specific path RR up to time t equals 2 is p. Now our current position at t equals 2 is x sub 2 equals 2. Is x sub 2 equals 2. To reach x equals 1 at t equals 3, the third step s sub 3, the third equals 3, the third step s sub 3 must be to the left. Leady videos do. Step which was right. The probability of taking the opposite direction given s sub 2 was right is 1 minus p. So the total probability of following this path, right, then left, which we can call path RRL, is the probability of s sub 2 being right times the probability of s sub 3 being left, given that s sub 2 was right. This calculates out to p times 1 minus p. So the probability of path RRL is p times 1 minus p. Now let's look at case B, where the first step was right and the second step was left. The path so far took us from x sub 0 equals 0 right to x sub 1 equals 1, then left to x sub 2 equals 0. The probability of this path right then left up to time t equals 2 is 1 minus p. Our current position at t equals 2 is x sub 2 equals 0. To reach x equals 1 at t equals 0. To reach x equals 1 at t equals 0 right to x equals 1. At t equals 0, the third step s sub 3 must be to the right. Taking a right step now means going in the opposite direction of the second step, which was left. The probability of taking the opposite direction given s sub 2 was left is 1 minus p. So the total probability of following this path, right, left, then right, which we can call path RLR, is the probability of s sub 2 being left times the probability of s sub 3 being right. Given that s sub 2 was left, this calculates out to 1 minus p times 1 minus p. Was simply 1 minus p squared. Alright, step 4, calculating the total probability. The walker reaches x equals 1 at time t equals 3. If either path RRL occurred, that was case A, or path RLR occurred, that was case B. These two specific sequences of steps are completely separate possibilities. They are mutually exclusive. Therefore, the total probability of being at x equals 1 at t equals 3 is simply the sum of the probabilities of these two paths. So the probability of x equals z is simply the sum of the probabilities of these two paths. So the probability of x sub 3 equals 1 is the probability of path RRL plus the probability of path RLR. Plugging in what we found, that's p times 1 minus p plus 1 minus p squared. Now let's simplify this expression. We can factor out the term 1 minus p from both parts. That gives us 1 minus p times in parentheses p plus 1 minus p. Inside the parentheses, the p and minus p cancel out, leaving just 1. So we have 1 minus p times 1, which simplifies nicely to just 1 minus p. So there you have it. The probability that our random walker is back at position x equals 1 at time t equals 3 is 1 minus p. This corresponds to option 1.